Okay, so electric circuits, it's a collection of circuit elements connected for a specific goal. Circuit elements have prescribed relationship between current and voltage at its terminals. Okay, so if you talk about any given element, for instance, the resistor, it has a prescribed relationship between its voltage and current, right? So for instance, V equals IR is the relationship for a resistor. Similarly, we have a relationship for a capacitor as well as for an inductor. Interconnection through wires. All points on the wire are at the same potential, no resistance in wire. All current entering one end of the wire exits at the other end. A wire does not accumulate any charge. So the point is, by the way, I don't have my touchpad with me, so I cannot really write on the screen, so please bear with me for today's session at least. So for instance, let me see if we have any examples. So for instance, if this is an example, what those 2 points basically mean is that if you have a wire, for instance, it starts from somewhere here and it basically ends here. Similarly, there is a tap over here. So this entire piece of copper, right? The statement, it's telling us that all points on this segments of copper have the same potential difference, or rather they have the same potential. So there is no potential difference between any 2 points. So you cannot say, for instance, if this is a black node and this is a corner, the fact that there is some potential difference between them, that's not the case. That would have been the case if there is a resistance between these 2 points, which there is not. So we assume in circuit analysis that the piece of wire, the piece of copper wire, has zero resistance. In practice, obviously, this is not true, but it is almost true since copper has almost negligible resistance. Then if you talk about the other point, all current entering one end of the wire exits at the other end. In other words, a wire does not accumulate any charge. So this fact is also violated in high frequency circuits. For instance, in printed circuit boards, you will find that we don't place these sort of corners, right? So for instance, if you talk about a PCB such as a motherboard, right, or any circuit board for that matter, such corners are not placed. They are either rounded off or we place an angle over here, right? The reason is that if we don't do that, then some capacitance will exist between at this corner and it tends to store charge. So these are things that you can study in high frequency circuits and PCB design. But anyway, that is not the topic right now. So as far as circuit analysis is concerned, there is also something called synthesis. So firstly, let's look at what analysis is. Analysis is finding specific voltages and currents in a circuit once individual elements and their interconnections are known. So finding specific voltages and currents in a circuit once individual elements and their interconnections are known. So this basically says that if you already have a circuit like this, it's already constructed, what you can do is simply analyze the circuit in order to find the currents through and voltages across any given element in the circuit. So once you have done that for all the elements in the circuit, we say that you have analyzed the circuit. On the other hand, the opposite thing to do is synthesis, also known as design, which basically means to choose a set of elements and devise their interconnections to achieve specific voltages and currents. In other words, if you want, for instance, a specific voltage at this point and a specific current flowing through this point in this direction, for instance, then you will have to design the exact the values of the exact components, right? In this region of the circuit in particular, and in general the overall circuit, you will have to design it. So that is called design, and that is the difference between analysis and synthesis or design. Acha ji. Then each element in a circuit constitutes a branch. Okay, so basically branch is another name for an element, right? So when you talk about a circuit, when we say branch, it's another name for an element. So basically you have 2 branches here. This is not a single branch, it's 2 branches. This is one branch and this is another branch. Each branch or element has a branch current through it and branch voltage across it. So for instance, if you were to talk about this branch here, there is a current I1 that flows through it. Then for this branch here, I2 flows through it. Yes, clearly, because these 2 branches are in series, or these 2 elements are in series, obviously I1 and I2 are the same, right? But these are still 2 different branches, and that is why the branch voltage across them would be different. So V2 is different than V1. Similarly, if you look at these 2 branches, then these two are different branches, but they are in parallel, because the 2 ends of this branch and the 2 ends of this branch, the one end of this branch is basically connected to one end of this branch, and the other end of this branch is connected to the other end of this branch. And therefore these 2 branches are in parallel. And when two branches are in parallel, the voltages across them, the voltage across them is common. So V5 is the same as V6. Of course, current is different. So I5 is different from I6, and these two are basically the sum of I4. So I4 basically divides up into I5 into the sum of I5 and I6. Current directions and voltage polarities must be indicated besides their labels. Okay, so whenever you have a branch, for instance X2, okay, so you label the voltage V2 and you label the current I2. So whenever you label a voltage V2, you have to specify the polarity, plus minus. Plus could be here, minus could be here, or vice versa. And similarly, if you have a current I2, you will have to specify the direction. You can say I2 in this direction or I2 in that direction. By the way, we have probably discussed this before as well, but I can also say this to be I2. This would be fine, right? And for instance, if I label this branch like this and I don't label it like this, does that make my label wrong? A question for the class. Just to know that, you know, you people are still here with me. The question is, I have labeled this branch differently. Instead of labeling I2 in that direction, I say I2 is in this direction. Do you think this is the correct, I mean, this is correct or this is wrong? अच्छा चलें ladies first वाला rule apply करते हैं. You mean to say it's starting from the corner? Exactly. बिल्कुल सही है. ठीक है. The other opinion, we had some other opinions as well. ओके, इलेक्ट्रॉन मोशन की वजह से होना चाहिए. ठीक है. इसके अलावा और कोई ओपिनियन? पैसिव साइन कन्वेंशन से बता सकते हैं. ठीक है. ओके, बिल्कुल ठीक है. अच्छा, सो at least the good thing is that you guys are at least building on top of whatever we have studied so far. But let's यानी एक तो पॉइंट बड़ा अच्छा आया कि obviously यहाँ पे क्योंकि बैटरी नहीं है और at least we don't know which of these elements is the battery, so we can't really say. Even if suppose that, you know, this was the battery, this one, right? And because the positive terminal is labeled to be this one, obviously current will move in this direction, right? Suppose, let's assume that is the case. But if this is the battery, even then we cannot say whether the current is in this direction or the other direction. As far as the element X2 is concerned, we can't really point out to the correct direction of this current. So my response to this entire dilemma would be that you can specify the current to be in this direction. You can label the current in this direction. It's fine. It's not a problem. This is fine. The original labeling was also fine. Okay, that is not a problem. Now, once you analyze the circuit, once you have completely analyzed the circuit, which basically means you know all the currents and all the branch voltages in this entire circuit, then for instance, if I had labeled the current in this direction like this, okay, suppose assume that I2 comes out to be 5 amperes. That basically means that this direction that I have currently specified is correct, right? But on the other hand, suppose the current comes out to be minus 5 amperes. That simply means that the direction that I have specified is, originally the current is actually flowing in the other direction. It's this direction. But that still does not violate my labeling. It still doesn't say that my labeling is wrong, because, you know, the current, that this big arrow that I have created here, okay, if you talk about this current, this is 5 amperes flowing in the right direction, but I2, as I have labeled it, is minus 5 amperes, which is fine. And if 5 amperes is flowing in the right direction, then I say, okay, minus 5 amperes is flowing in the left direction. That is still fine. Okay. So if I summarize the entire thing, then the point is that whatever labeling you do, ultimately the numerical value that you obtain and its sign is going to tell you the exact direction of the flow of positive charges, right? So it doesn't really matter. So I hope this point is clear, and as we progress through this course and as we do more and more numerical problems, then hopefully inshallah things will become clearer. Okay. So similarly, if for instance like if we find the voltage of the element X6 and assume it comes out to be minus 3 volts, let's assume that, right? Then it clearly tells us that the actual polarity is basically this, right? But if that would be the case, then we should write V6 equals plus 3 volts, because the polarity is now correct. But if the labeling of the polarity is the opposite, in other words, this is plus and this is minus, then we should write V6 equals minus 3 volts. So it's just that if you just can use the sign of the value in order to tell you about the direction of the voltage or the current, right? So this is just it's an important point, but it's a simple concept, hopefully, but it's an important concept that we need to keep using in circuit analysis. Okay. So let's move on to the next slide, branches. So let's see how many branches we have in this circuit. If you look at the definition of the branch, it's a single two-terminal element in a circuit. So if you count the number of two-terminal elements in a circuit, 1, 2, 3, 4, 5, 6, 7. So we basically have 7 elements in this circuit, right? Or 7 branches in the circuit. Segments of wire are not counted as elements. So this segment of wire, for instance, from this node to this node, this piece of wire, it's not really counted as a branch or as an element because it's just a piece of wire. When you draw the circuit, you may well, you don't necessarily need to draw these nodes, right? It's fine. You can also do away with these nodes. In fact, you can also draw this circuit in this fashion. You can also do it like this. This is a node. Okay, this is another resistor. This is a node. This is another resistor. This is a node. This is another resistor. This is a current source. Okay, and finally we have an 8 kilo ohm resistor here. You can also draw the circuit like this. Okay, this is a completely valid circuit. Okay, because I have sort of condensed this entire node into a one single point. Because whether you draw it as a single point or whether you draw it like this, it's still a single node. Acha ji. Then, okay, sorry. So examples of terminal elements is basically voltage source, resistors, current source, capacitors, inductors, and so on. Then we have something called nodes. Leads of 2 or more elements join together to form a node. So for instance, this black dot here, it's a node. And this is a node, right? So leads of 2 or more elements. So for instance, at this node, we have 2 elements, the 5 ohm resistor as well as the 10 volt source. These two connect at this point in order to give you a lead, in order to give you a node, right? Similarly, leads of multiple elements can also connect at a certain point. So the 5 ohm resistors terminal, the 2 ohm resistors terminal, the 3 ohm resistors terminal, and the 2 ampere source. All of them connect at point B, the node B, in order to give you a node, right? So all leads converge to a node. Okay, yeah. All leads converging to a node have the same potential, right? So the potential at point B and the potential at point C, when you subtract them, you get the potential difference or the voltage across terminals, across the elements 2 ohm, 3 ohm, as well as the 2 ampere source. But the point is that if you just talk about all these 4 leads, they are all at the same potential because all of them form the same node. So if we were to count how many nodes were there in this circuit, we can clearly see 1, 2, 3, 4, 5, 6, 7, 8. There are 8 nodes, right, in this circuit. I think I've made a mistake here. Yes, you can say there are 8 nodes, but 3 of these 4 nodes over here, basically this is just a single node, right? 3 of them are redundant nodes. Redundant basically means repeated nodes. Redundancy is repetition, right? So if you look at the definition of redundant node, you see that multiple nodes connected only by a wire. Multiple nodes connected only by a wire, such as on the reference node in the above circuit. So if you think of this as the reference node, you can see 3 nodes, you can just do away with them and you can draw the circuit as I had drawn here like this, right? And you just condense all those 4 nodes into one. So actually you just have one node here. So 1, 2, 3, 4, 5. You basically have 5 nodes in this circuit, okay? But what is the definition of essential node now? The point of connection between 3 or more branches. So essential nodes, there is something called a simple node, which is basically the node as we have discussed it. And then there is something called an essential node. An essential node is the point of connection between 3 or more branches. So basically there should be more than 2 branches. So for instance, at this node, you have just 2 branches here. So this is a simple node. But this node is an essential node because 3 branches connect at this node. 2 kilo ohm, 8 kilo ohm, 6 kilo ohm, all of them connect at this node. Similarly, this node is an essential node because 3 branches connect here. But this node here is again a simple node. This node obviously contains 4 branches. Basically, it's a point of connection of 4 branches. The 5 kilo ohm, the resistor, the 5 milliampere, current source, the 8 kilo ohm, resistor, the 10 volt, voltage source. So this node here is basically an essential node. Okay. Then what is a reference node? Since only potential differences or voltages have practical meaning, all node potentials are referenced to a common node called the reference or datum. Acha. So what they're trying to say is that basically when you say voltage, as we have discussed this before, the term voltage basically is the same as potential difference. And when you have some, basically, obviously, when would you have a difference? When you would have 2 nodes, because you would sense the potential at one node with respect to the other, and then the difference would tell you the voltage, right? So the node that is the reference node in this scenario, with which you are measuring the voltage of the other node, becomes the reference node. The bottom node is the most likely choice. Usually when we do circuit analysis, we typically just consider the bottom node to be the reference node. We also sometimes call it the ground node. The reason is that because of our tendency to visualize potential as height. So for instance, if you consider this circuit, and this is the bottom node, this is typically considered to be the reference node. The reason is that, all the other nodes, 1, 2, 3, 4, all these 4 other nodes are at a height compared to this reference node. And basically from our study of potential energy in physics, we come to think of voltage as potential and therefore as height, right? So that is why typically when we do circuits, when we draw them, when we analyze them, we typically tend to think of the bottommost node as the reference node. But that is strictly not the only possibility. You may as well consider any of these nodes, 1, 2, 3, 4, and 5. You may consider any of these 5 nodes as the reference node and write out the potentials or the voltages of the other nodes with respect to that chosen reference node. It's really up to you. And I think we have an example coming up. Yes, this is an example. But as I was saying, bottom node is the most likely choice, but sometimes more convenient to designate the node having largest number of connections as reference. So sometimes this is more convenient. Any questions so far? Okay, no questions. Acha ji, so this is an example. Ji, sorry. Okay, what was the first point? Let me see. ये जो point है ये वाला. अच्छा चलें, मैं इसको समझा देता हूँ. बहरहाल इतना critical नहीं है, but let's see what it says. It's trying to say since only potential differences ये इटैलिसाइज हुआ है. इस वजह से इटैलिसाइज हुआ है क्योंकि इस पे एम्फेसिस है. आपको जैसे हमने फिजिक्स में क्या किया है, पोटेंशियल एनर्जी पढ़ी हुई है. पोटेंशियल एनर्जी क्या होती है कि व्हेन एन ऑब्जेक्ट is at some height, it has some potential energy by virtue of its height, simply by virtue of its height, because it has acted against gravity. In order to move a certain object to a certain height, it has acted against gravity, and therefore it basically it has absorbed certain energy when a certain force has acted upon it in order to raise it up to a certain height, right? So that is our concept from physics of potential energy. Therefore, when we say potential difference, we tend to think of it in terms of height, right? So तो एक तो पॉइंट ये है कि कोई भी एक रेफरेंस नोड को टिपिकली हम बॉटम मोस्ट नोड कंसिडर करते हैं क्योंकि हाइट के ऊपर दूसरा जो नोड है उसका वोल्टेज हम कंसिडर करते हैं. दूसरा पॉइंट ये है कि what is the very requirement of having a reference node in the first place? मतलब why cannot you just pick up this node and say okay 3 volts at this node? वो है ये पहला पॉइंट. Because when you say 3 volts, तो because voltage by definition is potential difference, therefore ये जो difference है ये किसी ना किसी नोड के हिसाब से होना चाहिए. मतलब हो सकता है कि ये नोड 5 volts पे हो मिसाल के तौर पे और ये नोड 3 volts पे है. तो इसका मतलब ये है कि ये जो नोड है इस नोड के मुकाबले में -2 volts पे है, ये वाला, right? Because it's at 3 volts and this is at 5 volts. So this node is at 2 volts above this node. In other words, when I talk about the voltage at this node, I am now I must reference to some other node. ठीक है? इसी तरह से जैसे मैंने बोला कि इसके ऊपर 3 volts और इसके ऊपर 5 volts है, तो वो एक्चुअली वोल्टेज जो है, और वोल्टेज की डेफिनेशन है पोटेंशियल डिफरेंस, तो वो जो खुद वोल्टेज है वो किसी ना किसी दूसरे रेफरेंस नोड के कंपैरिजन में होगा. मतलब इसका जो 3 volts है, typically if I just tell you okay 3 volts here, so basically I mean it's 3 volts with respect to this bottommost node, because I haven't really specified the reference, so you will immediately come to understand, okay, this must be the reference then, because this is the bottommost node. So whenever a reference node is not specified, just think of the bottommost node to be the reference node, because ये फिर एक 0 volts के ऊपर होगा. ये पूरा का पूरा जो आपका नोड है ये 0 volts पे है, और ये अगर 3 volts पे, तो इसका मतलब this point is at a potential difference of 3 volts with respect to this reference node. ये चीज़ यहाँ पे मज़ीद क्लियर हो जाएगी hopefully. So when we talk about branch voltages, तो फॉर इंस्टेंस ब्रांच है x2, ठीक है, और इसका ब्रांच वोल्टेज है VAB, जिस तरह अभी थोड़ी देर पहले हम देख रहे थे, और उसकी एक पोलैरिटी भी हमें स्पेसिफाई करनी है. तो पोलैरिटी का मतलब ये होता है जहाँ पे नेगेटिव पोलैरिटी है ना, वो उसका रेफरेंस है, और प्लस का मतलब ये है कि हम वी आर टेस्टिंग द वोल्टेज एट पॉइंट A और चेकिंग और रीडिंग द वोल्टेज एट पॉइंट A विद रिस्पेक्ट टू पॉइंट B या विद रिस्पेक्ट टू नोड B. So basically, if you are using your voltmeter, digital multimeter, then you would put your red probe over here, and you would put your black probe over here. ठीक है? So this would give you VAB. अच्छा, उसके बाद when you want to read out the voltage at point B, for instance, with respect to this point, then again यहाँ पे minus है, यहाँ पे plus है, तो VB is basically, क्योंकि as you can see यहाँ पे VAB लिखा हुआ है, लेकिन यहाँ पे सिर्फ VB लिखा हुआ है. क्यों लिखा हुआ है VB? क्योंकि this VB is basically with respect to this reference, and this is the you can say this is the universal reference in this circuit over here. ठीक है, इसलिए यहाँ पे इसको हमने कोई सिंबल नहीं देते. मतलब ऐसा नहीं है कि यहाँ पे C लिखा हुआ है, वो इसलिए नहीं लिखा हुआ क्योंकि ये रेफरेंस नोड है, और इसको आपने एक यूनिवर्सल इस सर्किट का रेफरेंस के तौर पर ही लेना है. सो दिस इज ब्रांच वोल्टेज एंड दिस इज नोड वोल्टेज. Similarly, यहाँ पे VA जो है, this is a node voltage of this point with respect to this reference. But when you want to say the branch voltage across X1, you can also say VA, because एक टर्मिनल X1 का यूनिवर्सल रेफरेंस पे कनेक्टेड है, या बेसिकली ग्राउंड नोड पे कनेक्टेड है इस सर्किट के अंदर जो ग्राउंड नोड है. और VAB की डेफिनेशन होती है VA minus VB, where VA and VB are node voltages and VAB is said to be a branch voltage.